Notes 4, page 3. This is a page for mixed review using the multiplication patterns for multiplying binomials. So I wrote all 3 patterns up here so you wouldn't have to flip back pages. And I trimmed this for doing in class, but it doesn't matter what the terms are. If you have a binomial times a binomial, so that's 2 terms times 2 terms, the patterns are the same. So if the term is a cow, the term's a cow. That term's a pig. This is the difference of 2 squares. So it would be square the first term, cow squared, no idea what that looks like, minus pig squared. Done. All right. Now, we're not going to do easy review problems. We're going to do some larger problems like what will be on your homework. So we want to simplify this problem here. How many terms? Never forget to ask that. There are 2 terms. And what are we supposed to subtract here? The answer to this problem. And how could you describe that problem? Oh, that's the square of a binomial. The answer to the square of a binomial. So I'm going to set myself up for success. If I have to subtract the entire answer, that means I'm going to need parentheses that will remind me to subtract that entire answer. Okay, so it's this answer minus that answer. By the way, why don't I need parentheses here? Because it is this answer minus that answer. That's because there's an invisible plus sign in front of that term. And addition is associative. You can have parentheses or not. So if you want to put parentheses here, you can, but you don't have to. And I'm a typical mathematician. I write down as little as possible. So since I don't need them there, I'm not going to put them. Subtraction is not associative. You absolutely need parentheses to say, hey, subtract all of this answer. So notice what I've done. I've analyzed what I need to do before I dive in. Now I'm ready to dive in. I'm going to look at this term and say, ooh, that's a binomial times a binomial. In fact, it fits the pattern of the difference of 2 squares. So all I have to do is square the first term minus square the second term. Don't forget you got to square the 7 as well, minus 49x squared. Okay. Minus, oh, that's the square of a binomial. So I could do this in my head. Square the 2x, so that's 4x squared. Don't forget to square the 2. Okay. Scoop the 2 terms together and multiply them. That's 10x, but double that. And because that's minus, this will be minus 20x. Now be careful. Here's one of the most common mistakes for people who basically know what they're doing but make a careless mistake. The last term is positive. It's really coming from a -5 times a -5. So the last term is positive. Taking care of the sign, square the 5, 25. Okay? Now, if you do not like the pattern, I would suggest off to the side, you FOIL this. Because it's a square of a binomial, you can either FOIL it or use the pattern. But to avoid clutter, it might be good to FOIL it off to the side and then just put the answer in the parentheses there that we'd written. Okay. Now, just a few more steps. I need to distribute that negative and then see if I have like terms. So that's what, minus 4x squared plus 20x minus 25. Okay, so, and then there's nothing particularly pretty about the answer. Let's see, we have like a negative 53x squared. And we have a plus 20x. And then minus 21, combining like terms. All right, so let's try the next one. The only thing a little bit different about the next one really is I threw in some fractions, and you can expect fractions on your test. I'm not going to give you really big fractions to work with, but I just want to keep those skills up. So let's look at this problem, simplify. What should you ask yourself first, or what should you notice first? There are two terms. So it's this entire answer minus this entire answer. So right away, I know I have to get the two answers first and then subtract. But to get the two answers, what am I looking at? Each of these are binomials to square. So this is the square of a binomial. And as soon as I say that to myself, I realize, well, I got two options. I could FOIL it if I want to go the slow way, or use the pattern. Now, truthfully, on a test, I won't care which way you go, but we're trying to practice with a pattern, so that's what I'm going to do. So it's this entire answer minus this entire answer. So again, I could put parentheses here, then minus this entire answer. The parentheses here are optional because there's an invisible plus sign here. Parentheses here are absolutely needed because subtraction is not associative. So let's try the pattern to get the answers. Okay, that's the square of a binomial, so square the x, so that's x squared. And I really think it helps, until you get good at this, to do this little visual of scooping these and multiplying them and writing that down. That's 4xy, then double that. So when you double something, you just double the coefficient. So instead of 4xy, you have 8xy, plus square the 4y, don't forget to square the 4, 16y squared. See how much time and space that saves to use the pattern? Okay. Now, the back one, minus. Okay, square 1/2 x. Well, with a fraction, you might slow down. You're going to square 1/2 x. Well, 1/2 squared is 1/2 times 1/2, so that's 1/4 x squared. Okay. And that's the only fraction we're really going to have to deal with, as you'll see. Scoop these two together. It's clearing at x times a y, then it's half times 6. Well, what's half of 6? That's just 3. So when you multiply those together, you get 3xy, but then you double how many of those you have, so you double the coefficient, so that's plus 6xy. And then square the 6y, don't forget to square the 6, 36y squared. Okay, so there's really only one fraction we have to deal with now. So, next thing I'm going to do, these parentheses here, I can just drop them because it's a plus sign. Before I can drop these parentheses, I have to distribute the negatives, so that's the next thing. So this is x squared plus 8xy plus 16y squared minus 1/4 x squared minus 6xy minus 36. Oops, I forgot my 6. 36y squared. Okay, look for like terms. I see the x squareds are like. If you need to, put a 1 there. And let's make this simple. If I give you fractions that are halves and quarters, just think money. You have $1, but you lost $1/4. Or you spent $1/4. So how much money do you have left? 3/4. So this is 3/4 of an x squared. So plus 8xy minus 6xy is plus 2xy. And then plus 16y squared minus 36y squared is minus 20y squared. So, lots of things in this problem. 1, recognizing the square of a binomial. If you can use the patterns, it's a lot faster. 2, don't freak out with fractions. the work turned out to be pretty easy with the fractions. And then just something else which I probably haven't mentioned enough. Notice when your binomial has both an x and a y, notice the pattern in the answer. The first term has the x squared, the middle term has xy to the first, and the last term has the y squared. Just observe that, all right? So let's try another problem. So when you're asked to multiply things out, simplify things, always recognize how many terms are we looking at? It's all one term. It has 3 factors in that term. It's just, I mean, if you put a number in for x, like 1, this becomes 13. It's just a number times, and if x was 1, this would be 1, times a number, and if x is 1, this would be 5, times a number. Oh, I don't know why I did that. So it's really just a number times a number times a number. This is all one term. We got to multiply it out. Now, let's play this game, because I forgot to do it in my earlier notes. Can you predict the degree of the answer? That is, what will the highest power x will have in the answer? Well, think about it. What do you think? See, this is an x squared, which is eventually going to get multiplied by that x, which is eventually going to get multiplied by that x. So an x squared times an x is x cubed times an x. I think it's going to be degree 4. And is it predictable? Yes. So x to the 4th should be the highest power I see in this. Now, multiplication is associative. So when you multiply 3 numbers together, you can do the first 2 and then multiply in the third one, or you could do the second 2 and multiply in the first one. It doesn't matter, whichever is easiest. So, and sometimes it's 6 one way, half a dozen the other, but other times it is definitely easier to do it one way or another. So, for instance, if we were going to do 9 times 2 times 5, if you go 9 times 2 is 18, then you got to think, well, what's 18 times 5? I don't really know off the top of my head. But if you go 2 times 5 is 10, 9 times 10 is 90, that's actually easier. So if you look at this, do you see a pattern in anywhere? Yes, I do. This is the difference of 2 squares. So it's actually going to be easier to multiply those 2 together first. So, and notice how I did up here, although it's really sloppy. I'll multiply these 2 and then take that answer and multiply by the first factor. So I've got to copy this factor over. I'm going to multiply these 2. The difference of 2 squares, so it says just square the first term, which is 9, minus square the second term, and don't forget to square that 2, 4x squared. And now, there's another pattern. That's the difference of 2 squares again. So, see how that 9 and 9, 4x squared, 1 plus, 1 minus. So square the 9, which is 81, minus square the 4x squared, which is 16x to the 4th. And there it is. As we predicted, our answer is degree 4. So the patterns made that really easy. And the choice to multiply the back 2 factors first made it really easy. Okay. Now, the next problem is really trying to get you to practice to see some insight. This is not a binomial times a binomial. It is one term, but it's a trinomial times a trinomial. 3 terms times 3 terms. I don't have a pattern for that. And if we distribute, we actually have to distribute the x to all these 3 terms. We have to distribute the y to all these 3 terms, and the negative 5. We actually wind up with 9 little products. So it doesn't look like a pattern, but maybe there is, because the x plus y actually shows up here and here. So instead of writing x plus y, I could call that something else. I could call it a kitty. So x plus y, I'm going to substitute a kitty for x plus y. Don't judge my drawing. Okay, so x plus y, we're going to let the kitty stand in for that. Okay. Now, when I look at it that way, kitty minus 5, kitty plus 5, oh, that's a difference of 2 squares. Well, I know how to multiply that out of my head. I would square the kitty. You thought it'd be silly when I squared that cow before, but here we are, squaring kitties. Minus square the 5. Okay? Now, we're not done yet because kitty is just really, it's what we call a substitute variable, in this case a substitute animal. We just put in the kitty to make things look easier so we could see the pattern. Kitty was really standing in for x plus y, so now I need to do that. Replace x plus y back for the kitty. And then when I look at this, oh, x plus y quantity squared, that's the square of a binomial. I can do that, and I can do that in my head. I square the first term, so that's x squared. I scoop the 2 terms together and multiply them. That's just xy, but double it. So instead of having 1xy, I will have 2xy plus 2xy. Then I'll square the second term, which is plus y squared, and then minus 25. And that is actually the fastest way to multiply out those 2 trinomials.